What the f? I have here a GM throttle body engine control module out of a Chevrolet pickup from 1989. Though you'll find these things in nearly everything GM made with a throttle body injected engine from the mid-1980s well into the 1990s. This one has gone bad. A friend of mine was borrowing my truck to haul a car to the Atlanta area, and about 40 miles into the trip, the truck simply died. After checking everything from the fuel pump to the spark plugs, and with the help of a friend telling us a story about how a friend of his had a similar problem on their truck, we determined that we needed a new ECM. A few more trips due to our own hubris and not reading paper labels, we popped the PROM into the new ECM, and the truck was able to make it back home after 8 hours of going back and forth to the middle of nowhere. Not wanting to waste what could be a spare part, I'll be attempting to fix this module and then set it on the shelf with the correct label. During the process of rescuing the truck, and with a touch of curiosity and boredom, I poked inside this ECM to see exactly what went wrong. As you can see, this chip popped. This chip is a Delco 60904, a quad fault protected peripheral driver, and not typically available to the general public, from GM. Based on a 3rd gen Camaro forum and backed up by a Russian Opel forum, I found that a functionally identical Texas Instruments DS3668, which is also a quad fault protected peripheral driver, is available to the general public. I went ahead and bought a few and will be installing one of them. I haven't done a deep dive into reverse engineering this ECM, nor do I really intend to. But the end result of the Delco 60904 failing is that the ECM is unable to turn on the fuel pump and will refuse to fire the injectors. The inside of the module is coated in a conformal coating that prevents water, dust, vibrations from damaging anything inside of here. It's also preventing me from pulling this board out of this enclosure. So I'm going to need to use a little bit of light prying to get it out. Alright, so I've got the board out, and now the first thing I'm going to try to do is to desolder this chip off this board, and hopefully this browning I see on the board won't mean that there's terribly too much damage on it. We can only hope. As you can see, I got the part out, and it wasn't the most beautiful. On the board, it looks like I have possibly torn a pad or two. I had to kind of brute force my way onto it because this chip was literally glued to the board due to the conformal coating. I've also damaged this one diode here, but I should have an extra one just sitting around. And then my only other concern is that on this side of the board, there might be an issue with that component right there having too much heat applied to it, but I might be able to bodge this and throw some small wires in there and hopefully fix the damage that I created. Alright, so it seems like I don't actually have any of these in stock. There's 6336s, and I'll just have to order some, or possibly harvest one from another device somewhere. I'll just dig through my shop. In the meantime, I'm just going to try to clean this up and put in the new chip and hopefully get this thing working. As you can see here, the traces on the board are just absolutely garbage. Between the fact that this is a 30-year-old board that's been running around inside of a truck, to the brute force method that I used to remove said chip, and proceed to also destroy the neighboring diode, these just didn't have much of a chance. That said, I think I can recover this. I'm going to stick a socket in here and try to just run some wires, and hopefully I can get some continuity on these thankfully plentiful pads everywhere. Somehow, this garbage has continuity. I know, right? Not my proudest work, but it seems like it'll work. That is, if I can find a diode for this. I'm gonna rust around, see if I can find anything. If I need to order parts, I'll go ahead and do it. Regardless, from your perspective, I'll have found the part. I found the right part. I had to order it, and it's not the exact same part, but it should do the job. So I should be done now. I've soldered in the diode, stuck the capacitor on the bottom side, and socketed in the new chip. I've put hot melt glue on it to keep it from vibrating out of the socket. It should be ready. I'm gonna put this back together and then go out to the truck and see if it works. Welcome to the outside. This is my 1989 Chevrolet pickup truck. It's actually a Silverado trim. So as you can see, I have both the unit that I've just refreshed and the unit that's currently in the truck. I say currently, but after disconnecting the battery, removing the interior of the glove box, and fishing the thing out, it's not in the truck per se, but that's beside the point. What we're really here for is to test to see if the fixes that I did on this box work. The first thing we need to do is to get this panel off, stick the chips that are inside of here into this box, plug it back into the truck, reconnect the battery, and see if it starts. So GM ECMs use an interesting little package for their PROM chips. They allow you to pull them in and out of the ECM without bending the pins on the PROM chip. One thing to note is this PROM is actually an EEPROM, and you really don't want to expose these to direct sunlight for very long. I'm going to go ahead and put this inside the box so that I don't have to buy another one. Another thing to note is that these sockets are actually directional. They will not allow you to put the chips in backwards. All right, so I've installed the PROM chips into the ECM. I'm gonna go ahead and install this, cross my fingers, and hope that the work that I put into this actually fixed it. I am unbelievably happy that this works. I'm gonna go ahead and take this one back out, put the new one in, not because I don't trust my own work, but I bought a new one. I'm gonna use it until it dies, but this means that I have another one that I can stick on the shelf as a spare part. You can never have too many spare parts. Either way, I'm gonna do this quickly because the mosquitoes are eating me alive, and I'll catch you back at the workshop. So what have I learned from this? First off, I learned that I need to figure out a method of safely removing the conformal coating if I want to pull chips off an old board. I've already replaced the relatively large pair of snips that I used that destroyed a diode with one that's more appropriate. There's not a whole lot I can do about poor quality traces and pads besides a little more care, a little less heat, and just accepting that I'll ruin a pad or two. Besides technique, discussing with a few folks online, I learned that GM used the Delco Source CPU based on the Motorola 6800 family of microprocessors. So this ECM is more than just a dumb box running engine management duties. Not quite a Commodore 64 or an Apple II, but it is an 8-bit computer. I may still do some reverse engineering on this in the future, and possibly get some broken ones from the junkyard or a friend, and do some future silly project with the CPU and these things, provided I can successfully pull it without destroying the chip this time. I hope this repair was engaging for you, as it was for me, and I'm glad that you joined me for this endeavor. I got some good feedback from some of you on the last video, and it has given me a kick of encouragement. I've already got some ideas brewing and have a few things lined up in the near future. I've got a Twitter, and there I'll post occasional teasers and updates for this channel, and have a Discord that I've had floating around for a while. Links to those are in the description. Thank you for watching.